Hi everybody, it's Mrs. Casil for your third and final video with these vocabulary notes. I want to remind you I'm going to go fast, so pause, choose to rewind if you need to watch something, and if I'm going so slow for you, you can't handle it, remember you can fast forward. So we just finished these foldable notes right here, and now we're going to be adding these 4 tabs on this side. This includes drawing some graphs, so if you're a perfectionist or want to be incredibly precise, grab a ruler before we get started. Okay, ready? Okay, here we go. So the first tab that we have here, and you can see that I've written a label down here on the bottom left corner, is the mathematical way that we calculate displacement. Displacement is the change in position. We find it by subtracting the final position minus the initial position. We use x to represent position quite frequently, and we'll use a subscript f to represent final, and a subscript I to represent initial. Now, on the back of this tab is where this gets important for us when we analyze things. When we look at a position versus time graph, one of the things that's easiest to do with a graph is find the slope. You've been doing that since 7th grade, so if you don't remember how to find the slope of a linear line, go on Khan Academy and find some examples. Slope is rise over run, or the difference between your y-coordinates divided by the difference between your x-coordinates. And in this case, our y-coordinates position and our x-coordinates time. So the slope of this graph is the change in position divided by the change in time, which you notice here we've got displacement as our what the change in position is. This is what's equal to velocity. The slope of a position versus time graph tells us the velocity that object is moving. So for this example here that I just sketched out, I found the slope of the line was 2/3 meters per second. It's a slow moving object. The y-intercept is our initial position. That's where this object is starting. The second tab that we've got here is for acceleration. Okay? Instead of being the change in x, when velocity is what changes, that's acceleration. We calculate that by finding the final velocity minus the initial velocity. And that's assuming our acceleration is constant. That's an essential assumption to make. When we look at graphs where we have position versus time, if that velocity is changing, we end up seeing a quadratic changing slope. If that slope is, when there's a constant change in velocity or a constant acceleration, a velocity versus time graph has a linear slope that's increasing, or it could be decreasing. Again, position versus time graph, that quadratic curve means an accelerating object, or for a velocity versus time graph, a linear slope tells you the acceleration. Okay, our next tab here is for the time interval. This is the change in time between 2 observations. This is something you already understand. You look at the difference between times all the time. It's so funny. Our unit for time is seconds. Even though you might measure minutes or hours in your lifetime, we use seconds in science because most physical phenomena are very fast. So, usually, time interval and time can be used synonymously as variables. That's because we're usually in control of when we start measuring time. If you think about it, ask yourself, when was the beginning of time? Anybody know? Nobody knows. We press start on a stopwatch. That's usually when time equals 0 seconds. So when describing a physical phenomena, often you can just use your total final time instead of having to write delta t, delta meaning change. Okay, and our final tab, velocity, which we defined previously on our last foldable, is a change in position divided by change in time. Remember that change in position can be a positive number or a negative number. So here's our equation. Delta x divided by delta t equals v. So when you have a position versus time graph, the slope of that line, remember, is a velocity. That slope can be positive or negative. Right? These 4 simple mathematical relationships are what we'll be using to describe most of the phenomena about moving objects. We'll relate these in a more complicated way later. Have a great day, everybody. Thanks for learning with me. Bye.